Problem 1b, still want to solve for x. This time we're dealing with an absolute value inequality, which means we need to split it up into two separate inequalities. A positive version that looks exactly the same except it doesn't have the absolute value, and what I will refer to as a negative version where the inside of the absolute value is the same, but we flip the sign and we flip the sign, by which I mean change the inequality from a less than or equal to a greater than or equal to, and change the positive one to a negative one. Now we solve both inequalities simultaneously. Since this started off as a less than or equal to inequality, I know that this will be an and inequality. Less than, great or. All right, so 2x is less than or equal to, let's subtract 3 on both sides. So 2x is less than or equal to 1 minus 3. 1 minus 3 is negative 2. Divide by 2 on both sides, x is less than or equal to negative 1. And 2x is greater than or equal to, again, subtract 3 on both sides. Negative 1 minus 3 is negative 4. Divide by 2, x is greater than or equal to negative 2. So x is less than or equal to negative 1 and greater than or equal to negative 2. We should write it as a compound inequality. X is greater than, let's do it this way. X is greater than or equal to negative 2, and x is less than or equal to negative 1. So that would be our compound inequality. If we wanted it on a number line, we could go 0, negative 2, and a positive, what am I doing? And a negative 1 right there. And we want the solution where x is between or equal to those numbers. So we'd have a closed-in circle there, a closed-in circle there, and a line connecting those two numbers. If we wanted to put this in interval notation, we would say that x is in the interval starting at negative 2 and continuing up to negative 1. I used brackets, not parentheses, because we are including those numbers, because it is greater than or equal to and less than or equal to those numbers. So there you go.